Hello, computer science students. I wanted to do 3 parallel examples that show how you use that pattern for finding the maximum in some different settings. So, because I think a lot of the trouble that people had was not recognizing the similarity between different kinds of problems and getting confused about sort of which parts of the pattern to keep and like how do you adapt it to a new situation. So we're going to find the maximum value in an array, we're going to find the maximum digit in an int, and given an array of two-dimensional points, we're going to find the maximum distance between some pair of points in the array. So in each case, you notice we're finding a maximum in some sense. Okay, we'll start over here with max array value because that's the most straightforward example. So here's the straightforward pattern. I'm going to create an integer called max so far. What I'm typing right now is wrong. This is wrong. Well, it's a bug, and I'll show you why in a second. But we're going to initialize some maximum value we've seen so far, and we're going to initialize it to be small. Now we're going to visit all of the possible things that might be larger. So I'm going to start, essentially I'm just going to loop over the array. So I'm starting at 0, I'm going to go to the end of the array, and then for each thing in the array, I'm going to ask, is this thing larger than the maximum thing I've seen so far? And if the answer is yes, I'm going to save it as the new maximum thing I've seen so far. And once I've visited all of the things, because I'm comparing each thing with the biggest thing I've seen so far, at the end of this, I should be able to return the maximum thing I've seen so far. Okay, so what's the bug here? This is going to work just fine as long as all of the values in the array are positive. But what happens if I have an array that has all negative values? In that case, none of the array values are going to be larger than max so far, because that's 0. And so at the end, it's going to return 0 as my maximum value. But 0 isn't even a value inside the array, because I said all my array values were negative. So it's going to return an answer that isn't true. So we had said in class a couple of times there's 2 good solutions to this. One solution is you can set this to be the smallest possible value. So integer dot min value. So there's 2 possibilities here. Either your array is an array that contains all the values as being equal to integer dot min value, in which case this is never going to be true, but it won't matter because all our values are integer.min value, so the maximum that I'll return is still accurate. Or a lot more likely is it'll be an array full of different numbers, and the first number we hit that is not the minimum possible integer is going to replace the max that we've seen so far. So that's one solution. Another good solution is let's initialize this to be the first element in the array. Then we can start searching from the next element in the array. And that's also going to be safe. All right, so far so good. So let's do the same thing for max digit now. All right, well, what's got to be the same? The pattern needs to be the same, where we need to loop over all the things that we're interested in. So we'll need to loop over all the digits. We'll need to initialize something called max digit so far. And we'll initialize that to something small. I'm looping over all the digits. I'm going to get a digit, get the digit that I'm interested in seeing, and I need to see if my digit is larger than the max digit so far. So, and if it is, then max digit so far is going to be equal to my digit. So this is all pseudocode. So you see the pattern's the same. What's different is, in this case, to visit every single element in the array, we used a for loop. Here, for the int, there is no really clean way to use a for loop. Instead, we use that pattern that we did a bunch of times in class. If I want to get every single digit one at a time, I'll do this. I'll say while n is bigger than 0. I'll get a digit out, and I'll do that by doing n mod 10. That gets my digit. Now my digit is saved in the variable digit, so I'll see if the digit is bigger than the biggest one so far, and if it is, I'll save it as the biggest one so far. And then the last step is I'll say digit equals digit integer divided by 10, which chops off the the last digit, so it'll truncate the last digit. Okay, so this is the same kind of overall pattern, only the details of how you loop over the things that you want to loop over have changed. Oh, let's not return 0 at the end. Let's return max digit so far. All right. So last example is, let's find the maximum distance between the pairs of points in here. So here, I don't want to loop over each individual thing in an array because I'm interested in the distance between points. So I need to visit every single possible pair of points in this array. So let's start the same way. I'll initialize my max distance so far, and I'll initialize it to -1. And I know this is safe because all distances are going to be 0 or greater. So if I initialize it as -1, that's smaller than any distance I might possibly see in this array. And so I know that this is going to get replaced the first time I go through my loop. Same thing over here. I didn't even need -10. I could make this -1 because there are going to be no negative digits here. I guess I should have also said we're assuming here that this input n is positive. If you wanted to force it to be positive, you could say n equals math.absolute value n, and now it is. Okay, that's neither here nor there. So here we are back at maximum distance between pairs of points. So in this case, we loop over every element in the array. In this case, we loop over every digit in the int. In this case, we want to loop over every pair of points. So I'm going to start by having I excuse me, visit every point in the array. And if I want to, here, let's make some point variables. So I'll call them A and B. And I'll make my point A be equal to the points at at index I. So now I'm going to loop through all of the other points that I might be paired with. So I don't want to start j equal to 0 because if I get the point at j, now I'm comparing the points at index 0 with itself, and that distance is going to be 0. And I don't want to do that. So I want to only visit all pairs of points that are not the same point. So I'll say j is going to start out at whatever the index is after the first point, and then I'm going to go to the end. And now let's set my b point. What is happening? So b equals array j. And now I can calculate the distance. So let's assume that I have a distance method that will calculate the distance between these two. And you can write that. That's just the distance formula. We've done that before. So now I could say if the distance for the pair I just looked at is larger than the max distance so far, then I'll save as my max distance so far this new distance I just calculated. And then at the end of that, I've looped through all possible pairs. I've checked each one to see if that pair's distance is the largest. And so at the end, I can return max dist so far. So, what does it know like here? What's a double? What's an int? Oh, I shouldn't have made this an int, because if it's a distance, they should be doubles. Great. All right, so I hope this has illustrated how you can take the same high-level pattern of looping over all the things and comparing each thing to the largest so far. That same pattern can actually get implemented in several different ways. And what might change is you might need to initialize your max so far to different values, or the exact way that you loop over the things that you need to check is going to be different. Because sometimes you're checking the actual things in the array, sometimes the array is going to give you the raw elements, but you actually want to check distances between pairs of them, so that's why you would need the double nested loop in order to get all the pairs of points. And then you would calculate the thing that you actually want to check, which is the distance. So I think the best way to get good at this, good enough to do it on your own and be confident that you're going to write it correctly the first time, is to just do a whole bunch of examples yourself. So I should have emailed you recently just a whole long list of examples, and I would say crack to it. And it's really like relaxing and fun once you, it's like doing Sudoku, like once you feel confident you know these patterns, because you're confident enough you can just type them out and you know they're going to be right, and it's just very wonderful. Okay, good luck, everyone.